Hey guys, today we're going to talk about exponential growth and decay. Make sure you write that down. That's the title of this topic. And we'll continue on. So these are some of the vocabulary words: exponential growth function, exponential decay function, compound interest. We're not really going to do compound interest today, but it is within this unit. All right, so the first thing we're going to talk about is exponential growth. So I just want to backtrack for a second. What we've dealt with before, we've dealt with other functions. The word function should come in mind. We've dealt with linear function, right? We drew a line. We graphed a lot of lines. So now we're talking about exponential functions. So it's not a straight situation. It's a situation where something is growing exponentially, right? So it creates more of a curve, whether it's growing up or it's decaying down, it's still that curve, okay? So exponential growth occurs when a quantity increases by the same factor over equal intervals of time. So every day, every month, every year, every 10 years, whatever it happens to be, it's equal amounts of time, and it's growing by the same factor, okay? So that means multiplication every time. So the important component of this, let me just move this here so I can get my pen. All right, awesome. So the important part here, the equation, the formula that represents exponential growing is this here. So make sure you write that down. I want to point out that A has to be more than 1 and R has to be, backtrack. A has to be more than 0 and R has to be more than 0, and this is the exponential growth function, okay? Now, what does that all mean? So you're going to see that the equation here has different parts, so make sure that you leave space, just like I did, to kind of title each part. And I did my best, but it's definitely not perfect. So let's start with what A is. Well, A is the initial amount. So that initial amount's going to come first in that spot there. And then the equation has 1 plus. So it's still 1 plus R. And now R, if you notice my arrow doesn't really point to R. R is more like here, okay? So ignore that arrow. R is the rate of growth. The rate of growth, and it needs to be in decimal form. So for example, 25%, and obviously I'm going to rate like a toddler because I'm using that mouse pad, right? So it's not easy. So 25%, let's think of how that is as a decimal. If you remember, the decimal moves 2 places to the left, so it's 0.25. Okay, so just keep that in mind. If you have 3%, that's 0.03. And, you know, we'll work with that as it comes. So T, it's a little bit hard to see here, but my T is gray. I'm going to highlight it. My T is gray. That's my time. And time is in years. Okay, and then a big part here, if you see this, butterfly looking thing here, that's represented for the 1 plus R, just that piece right there. That's the growth factor. Sometimes you're going to be asked just what is the growth factor. For example, if your rate, whoa, I didn't mean to do that. Is there an undo button? If you're, I don't even know. Oh, eraser. So if your rate is 25%, and they ask for the growth factor, so then you're doing 1 plus 0.25, which is 1.25. So the growth factor would be 1.25. Okay? And then the last part is, what is it equal? What's that Y? And that Y is the final amount. So, you know, each scenario, this is real life. So each scenario is going to be different. If you buy a house and it's growing, the price of it is growing, you would use this kind of formula. Let's say after 2 years, it's worth a different amount. So that's why there's variables here. So to represent time, time is going to be one part, and then Y is the other. But the initial amount, when, you know, I bought my house or you bought, you know, whatever it is, your car, whatever, that initial amount should not change. If it does, it's a new formula. It's a new function. And then your rate, each time you're working with this, it should be that same rate as well. So y and t are your variables. Now I'm going to show you, this is exponential growth. I want to show you exponential decay. So here's decay. Notice it's precisely like almost all the same. There's one little bit of detail that's different here. Exponential decay occurs when a quantity decreases by the same factor over equal intervals of time. So because it's decreasing, the difference is that everything is the same but that subtraction sign. So I didn't, have the pop-ups come out here. I wanted to show you A is still your initial amount, R is still your rate of decay, T is still your time. Here it says decay factor. 1 minus R is your decay factor. That's going to be different because it's not a growth factor. It's decaying at a certain rate. And then your final amount is your final amount. Any point you need to pause the video, you need to backtrack. That's why we have a video. You can do that. All right, so let's go with an example so you understand where this is all coming from. So we're going to talk about a concert, specifically a rock concert if you're into rock music, or maybe if you've been to another kind of festival. This is fun. Okay, so in this festival, some of it is blocked. I can fix that. In this festival, the first year, before the very first year, year zero, I should really say, there were 150,000 people. The attendance increases 8% each year. So those two values are crucial, my initial amount and my rate. So now my rate has to be changed to a decimal, right? That's the first thing I'm thinking. So 8%, if I write 8%, and it's not going to be easy, 8%, I'm moving the decimal place how many places? 2. So 1, 2. There's a space here, so I need to fill it with a 0. So this equals point, or 0.0, and now this 8's going to be bad. I can feel it. Ooh, not bad. 0.08. And now the first part of this, part A, says write exponential growth function that represents the attendance after t years. So the parts that we needed to know was the initial amount and the rate of growth, right? So 0.08 and that 150,000. So this is our formula. It's growing. It's growing. So I'm going to be increasing. So I need a plus. That's why this is a plus here, right? The equation, the difference between growth and decay was that plus or that minus. Because it's increasing, that's the word here, increasing, that means it's a plus. Okay, so now all I do is plug in, right? My A is 150,000. My R is 0.08. These are the two values I add in, and now I can add. It says add, so we should add. What is 1 plus 0.08? And that's the really nice part, because it's going to be just like 1 plus that amount, so 1.08. And now this is the formula. There's nothing to do here other than write the answer, and that's what I'll show you here. The festival attendance can be represented by y equals 150,000 times 1.08 to the t power. Now, when you're plugging in the number of years, like there's usually a second question that says, well, what about in 5 years? What about in 10 years, right? Things like that. That's where I'll show you the math of it. Okay, so the second question is asking, how many people will attend the festival in the 5th year? And here we have to be really careful, because the year 1 is not year 1. It's the starting year, so it's year 0. So I have 0, 1, 2, 3, 4. So my 5th year, my t is 4. So you got to be very careful of that. T equals 4 in the 5th year. And I hope that makes sense using your hand to like literally 5th year, because it's 0, 1, 2, 3, 4. Okay, and now my function is y equals this whole function, right? And now all I'm doing is plugging in that 4 for t. Now I'll show you that in a minute. I'm going to actually make me very large here and show my my whiteboard behind me. So, and ignore the stuff that's already on there. I'll use that in a minute. So where's my blue? Okay. So the equation is y equals 150,000, 1.08 to the 4th power. So that's 1.08. That's kind of hard to see. 1.08 to the 4th power. So how you're going to put this in the calculator, if you're using the computer calculator, chances are that is going to use, it's a smart enough calculator, can figure it out. But if you're using like maybe your phone calculator, how I did it on my phone was I turned it, because it's an iPhone, so I turned it, and then I hit that X to the Y button, and I put 1.08, hit this button, and then put a 4, then multiply it by 150,000. Okay, that's the order. All right, so back to this screen here. Okay, so back to the screen. So now the next thing to do is to do the math, right? Substitute. So we're substituting t equaling 4 and then plugging it in. And if you notice, let's use purple. If you notice, the calculator should give you, and you should test that out, 2004.073, and it probably even has decimals after that. And we're rounding. So because it says to round to the nearest 1,000, this is where my thousands places, where that 4 is. Because it's a 0, just to remind you of rounding, it stays as a 4. So the answer is about 204 people will attend the festival in the 5th year. Notice there's a lot of real life here, so you're going to see real answers. You're not just going to write 2,000 and 204,000. You're going to write a sentence because it's about a real life situation. Okay, so this is about growth, about increasing, about a real life. Let's talk about decreasing. Where did my candy go? All right, so I have, we're all home. I have a jar of candy, and I'm noticing it's going down. It's going down, right? So using my time in days, let's just keep it simpler. So it's in days. I noticed I had 1,000. That was what the box, whatever I bought it from, said. I have 1,000 M&Ms in my, and I put it in a candy bowl, and every day it's decreasing by 10%. So the first thing you need to ask yourself, decreasing, is that going to be, let's move this here, is that going to be 1 plus r or 1 minus r? Am I decreasing? I'm decreasing. So decreasing, that's that decay, right? It's going down. I started with 1,000 M&Ms and now 10%. So my equation is y equals 1,000 times 1 minus 10%. Ooh, I got to change that to a decimal. So move the decimal 2 places. So it's 0.10. 0.10 to the t power. So that's the function, but I do need to subtract. Just like before we added, now I need to subtract. So 1 minus 0.10. So like $1 minus 10 cents. That's at 90 cents. 0.90 to the t power. You don't need that 0 after the 9 if you just put 0.9. So that's the function. If I ask just what's the function, that's it right there. And then, the question could differ, right? I could say, well, what's going to happen in 10 days? So that would be this. In 10 days, there's going to be 349 M&Ms left. And then I tried to pick different amounts, like trying to get down to 0. So I started with 15, 30, and then I'm just using my calculator. I'm plugging it in. I'm getting different values. After 15 days, there's 205. After 30 days, there's 42 M&Ms left. After 105, there's 0.02. After 110, there's 0.01. And we're talking M&Ms. Once it got down to less than 1, there's no more M&Ms, right? Because you've got 1 left, and then if it's less than 1, then it's no more. So just be careful. If the question ever asks you, when will you have none left? It's kind of hard to answer that question because you're always going to be, you're dividing by an amount, by that factor. So it's always you're never going to get to 0. You'll get really, really close. All right. So let's have fun with this real life. It's kind of nice to have some real lifeness to it. And that's our lesson today.